All right, P4, lines in the plane. So basically, this is just a whole bunch of graphical forms and what they look like is really all these notes are going to consist of. So slope of a line, m equals delta y over delta x is equal to y2 minus y1 over x2 minus x1. Okay, the little triangle with the y and the x there, it's a delta symbol. Okay, it just means change in, which is just one of them minus the other one. And then just a little note about that. If the line is vertical, then x1 is equal to x2, and the slope is undefined, because that would make the denominator be 0. Point slope form. I will tell you this is the most beneficial form for any math you do beyond this, because it's pretty much what everything has to be in for calculus to get information. So there's two ways you can write it. The way I always wrote it is this: y minus y1 is equal to m times x minus x1. So the x1, y1 is the point that you're given, and then obviously m is your slope. Now, that's not to say that they won't sometimes give you 2 points. You have to find your own slope, and then it doesn't matter which point you use. Okay, both of them will give you an equation of a line. When doing problems, sometimes if they do give you 2 points, I don't think when I do my answer key to write both options down, I'll only write one of them. So if that's something that you're ever like, but I used the point here, it just wasn't the one I used or something like that, just let me know, because sometimes I don't catch that.
So where do you get like the y and the x? Is it y equals
The one that doesn't have a 1 with it, that is just going to stay a variable.
Oh, okay.
So that when you modify this, you could ultimately come down to y equals mx plus b,
Okay.
is what it's going to give you. Now, the way that the calculus book that we have here writes this equation, and I'm not sure if your book does it this way, I don't think it does, because I'm pretty sure the calc book was the first one I ever noticed this in, is y is equal to m times x minus x1 plus y1. Okay, ultimately that y1 is getting moved over, so it's fine to go ahead and start with it over there if you want. But pretty much anytime I ever set it up, you're going to see me use the top one because it's habit. I've used it since I was like sophomore, junior in high school, and so, you know, something works, don't change it, right? But like I said, since the calc book uses it, I wanted you to be familiar with this. Both of them are acceptable. If I tell you to write something, just if I simply say write it in point slope form, either of these is fine. I'll take either of them. If it says to leave it in point slope form, don't convert it to slope intercept form. Leave it like this. If I just say write an equation of a line, you can use your favorite method. So, slope intercept form then. To write it in this form, you have to be given a slope and a y-intercept. Now, again, I may say write your answer in slope-intercept form, but I may give you the information to start in point-slope form. So you may have to go from point-slope form to slope-intercept form. But again, that's a distributive property and then an addition or subtraction. So it's not like it's that bad. But that's equal to, or y equals mx plus b. One that we probably haven't really used a whole lot. It does come up. I know it even comes up in Algebra 1 because we were looking at it the other day. But general form, got ax plus by is equal to c. And the only thing that has to be true is that a and b cannot both be equal to 0. Okay, so with these, this is where you can use the cover-up method and plot points. You can plot something on the x-axis and something on the y-axis, and then just draw your line between the two of them. A vertical line. Something like x is equal to a. Horizontal line. Y is equal to a. And then let's see, what do y'all know about the slope of parallel lines?
And
Zero.
parallel lines are so consistent. I didn't mean that.
Parallel lines have the same slope. How about perpendicular lines?
They're opposite and inverse.
Opposite. It's like upside down.
And they're inverses, like one will be negative and the other will be positive.
Yep. Perpendicular lines must have slopes that are the opposite, inverse. So something like M1 is equal to 1 over M1, and one of them would have to be negative. So you're always going to have one negative and one positive one when it comes to that. And this one will have, since I write big, probably ballpark 2 pages of examples for you guys.
That was easy to miss.
Maybe, maybe not. I don't know. I would say probably leave 2 pages just
Are we taking any more notes?
because, no, that's it for this section.
Literally, it's so tiny.